This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. This podcast series is sponsored by Allied Electronics and Automation, carrying the most automation and control brand names in North America. Now, the questions posed in this podcast series all come from automation technology users like yourself across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is, do servo motor, drive, and controller combinations really work better if they're purchased from the same vendor? Now, this question hits at the heart of a great deal of automation device interoperability issues, particularly as we move ever deeper into the age of digitally connected automation. So to get some detailed insights on this, I'm joined today by Eric Roggeman and Greg Dieck of Omron Industrial Automation. Omron supplies an array of automation technologies, from sensors and control and safety components to motors and drives, robotics, and power supplies. So, Eric, let's start by giving us an insight into what you typically see in most manufacturing environments. And by that, I mean, do most manufacturers buy servo motors, drives, and controllers from the same supplier, or do they more often tend to mix and match?
Thanks, Dave. So that's kind of a two-part question. When it comes to the motors and drives, we see that those are typically bought together, and unless it's some kind of special application where you have an explosion-proof or hygienic type motor that you need, and you need a specialty brand of motor. Otherwise, the motors and drives usually work better together when they're from the same manufacturer. They're kind of keyed to work together. They talk right away. You don't need to do any kind of special configuration between the motor and the drive to make sure they're speaking the same language per se. When it comes to the controller and the servo drive, usually the servo is connected to the servo drive is connected to the controller, not directly to the motor. Those are usually purchased from the same supplier for most applications. Again, it helps with some of the communication, and it kind of gets rid of some of the specialty hardware or specialty configuration that you might need to do between a controller and a drive. And overall, it makes the whole process a little bit more seamless. It's kind of more plug and play rather than the puzzle of putting together two brands that might not want to talk to each other quite as well.
Okay. And for those mixed servo motor drive controller combinations, is cost the driving issue for this, or is it done more to achieve particular performance requirements?
You want to take this one, Greg?
Yeah, this is Greg. Normally it's performance. And as Eric mentioned, a lot more of times it is these specialized applications. So when you're getting into food grade, they need the new hygienic standards, or an explosion proof for something like a dusty environment where the dust could possibly be flammable, or a paint booth. It is done sometimes for cost, but normally we see it much more for a performance.
Dave, I would just add to that is safety is becoming a bigger and bigger topic as we put together more of these applications, and manufacturing plants get a little bit more sophisticated with also with the litigious nature that we live in. The controller and the safety system and the motion components all working together and being redundant and seamlessly talking to each other is a big focus these days, and people want to make sure that they have that right on the onset of their machine, their application, rather than paying for it down the road.
Understood. Thanks for clarifying that. So, looking at these motor drive controller combinations in general, what are the key aspects of each of these three components that manufacturers should consider to I guess, make sure that each of those components are compatible for a particular application?
This is Greg. So a lot of times what we're looking at the topology of the whole machine. So we're looking at it from the controller to the drive communication. A lot of times we're trying to use open networks. There are some proprietary networks still out there, but a network that's going to be very high speed, deterministic, easy to configure for the customer, which also then when it's in production is going to be easy to maintain. Cabling, depending on the machine design, make sure that the cabling is very flexible. Make sure that we can either run a daisy chain or a string topology, as well as be able to do like a branching and do like a star topology. Eric mentioned earlier that safety is becoming more critical. When you start bringing safety into the controller and the drive, at that time the network becomes even more demanding, because now we're running safety on top. So you're really looking at trying to make sure that all of the elements are going to all work well together So as you're manufacturing, they're easy to be able to set up and configure, but at the same time, when it's running in production, be able to maintain and make sure you get a very efficient, high efficiency production as well.
So, are there any specific aspects about these devices that can be easily noticed that would clearly show a user whether a particular motor, drive, or controller combination would not work well together?
Yeah, so this is Eric. Mostly you want to make sure that the communication protocols, as Greg mentioned, are the same. So if you have Ethernet IP or EtherCAT, you want to make sure that you get a drive and a controller and a motor that are all coming from the same family of networks so that they're speaking the same language per se. You also want to consider the encoder communication. There's a few different types of encoders, SSI, NDAT, or quadrature, that are all kind of talk to the drive differently from the motor encoder. Just to make sure that their positioning is right on, that the position sent by the motor is received by the drive, communicated to the controller, and that all three components are on the same page, and that the motion application, the position that is shown is indeed the position where the motor or your product is at, just to make sure everything's accurate and you're trying to stay away from any kind of defects or stalls of any type. In addition to that, obviously you want to just look at the cabling connectors from motor to drive and to controller. If they're all RJ45, or if you got a power and brake cable, but you don't have a drive that has a braking, that has a motor that uses brakes, then you want to make sure that those are all compatible or kind of on the same page, just to make sure everything fits together. It's pretty basic stuff, just when you're looking at compatibility, but overall it's just still a box you definitely want to check.
And one follow-on question here to that. I know we've talked a bit this morning about the different communication protocols in connecting these various devices together. And there's obviously been a lot of discussion around Industry 4.0 and the industrial Internet of Things about open communications between those. But most of the applications that we see those are more for like sending data or extracting data from a motor drive controller for use in a historian or cloud applications. Do any of those communication technologies come into play here in these motor controller drive combinations? Or does it need to be, as you mentioned, very specific that they're speaking the same protocols among each other?
So when you're looking at, this is Greg, when you're looking at collecting data from a controller, there are multiple networks that we can use, multiple protocols. When you're looking at controlling motion between the controller and the drive itself, you want to make sure that you have a very high speed, but mostly you want to make sure you have a deterministic network. That allows you to be able to pass data without any delays between the drive and the controller, which will update your positions and be able to actually make sure that your machine is running very efficiently. If you have some of the more data-orientated communication protocols, they can have packet collisions and such, and actually delay your motion and cause inaccuracies in your machine while it's running. So there's two different types of networks that we see for the machine. We see the deterministic high-speed networks for kind of the backbone of the machine, where you're going from the controller to the drives. And then we use different protocols normally for data collection from the controller up to a system for doing traceability or for doing a SCADA type of a software package at the top end of the machine.
All right, thanks for explaining that, Greg. That's something I felt that we should probably address in this with all the discussions around industrial communications and networking lately. So it's not a surprise that servo motor drive controller combination from a single vendor would work together as specified. But do these same supplier combinations really work better than a mixed supplier combination?
This is Greg. There are some distinct advantages when you use a single supplier. A lot of times it comes down to software. So with the software, you have to do all of your configuration of your access. You have to do your tuning. And then once everything is up and running, you have to do your actual programming. So if you have a single software package from one vendor, one, it helps to be able to maintain a single tag database, and it gives you a single software to learn, so the learning curve is faster. Sometimes if the vendor has some things, is very used to doing this, they will do things like drive parameter backup. So if you're making multiple machines, you can actually replicate the machines very quickly. In the field, if something fails, you simply have one software package to be able to download the new drive parameters, get the machine back up and running very quickly. We also see some advanced features from some of the companies as far as multi-axis tuning. So if you are running a gantry system or a Cartesian system, you can actually tune all the axes together, which gives you better accuracy in your machine. That'll help customers be able to achieve better throughput on the machine, also maybe avoid some waste. We also see things like some advanced vibration suppression. So if all the axes have a mechanical link to a particular part that vibrates, you can actually do multi-axis vibration suppression, which can help to make the machine last longer mechanically and make better quality parts.
Thanks, Greg. Now, what are some of the reasons that an end user might want to mix and match a servo motor, drive, and controller from different suppliers?
Thanks, Dave. This is Eric. So I think I mentioned it earlier, but there are some applications, especially in the oil and gas industry, that require explosion-proof or NEMA standard motors. Some vendors don't have those. For instance, Omron does not sell an explosion-proof motor, or an IP69K motor, or hygienic motors for packaging or washdown applications. Not all people that make drives and motors make those types of specialty motors. So a lot of companies use some universal drives that you can go through the configuration process of using two different branded, or a motor and a drive from a different brand. Like I said, it's a little bit more intensive programming experience. You'll have to do a little bit more on the front end to make sure they're speaking the same language. But that is one case where you'd have to use different brands. And then another one might be size requirements on the motor and drive combination. So maybe you have a controller and a drive and you really like the way those talk to each other, but then the motor you have is just not offered by that brand. Sometimes you want to keep the controller as the PLC that you know and love, that you know how to use, and that you're very used to that environment. But you need a little bit more horsepower. Maybe you need a 50 kilowatt motor or something like that. That the brand of PLC you use, that manufacturer does not make that size motor and drive combination. So you might need to mix and match a little bit there, which also leads into that a little bit more intensive configuration process to make sure that they're on the same terms. And then there's also specialty motors, like direct drive motors or geared motors, or pre-geared motors, that again, some brands don't offer. So if you need any of those and you have a kind of a specialty application, that's really the only time that you'd want to mix and match a servo motor and a drive. But really the controller and the controller is most probably going to be the biggest preference among customers. What kind of programming environment they like for their machine overall is probably going to be the decision maker. And then they'll pick the drive and motor combination based on the specific application that they're trying to solve.
Well, thanks for explaining those different aspects of the decision-making process there, Eric. And I believe my final question here for today is, are there any maintenance issues that would make purchasing a motor drive controller combination from a single vendor more advantageous than doing a mix and match approach?
Yes, there are. This is Greg again. By having a single source, there are some distinct advantages to that. One, we go back to the single software. So when you're doing your configuration and you're connecting to it, it's one software package going to it. But on top of that, you start looking at troubleshooting for one off of the machine, but also maintaining the machine when it's going. By having one vendor, the controller automatically knows what the error handling for the drives are. You can bring a centralized error handling to the machine. This is key not only to troubleshoot as parts fail, but now you can actually also add in errors that are machine specific, not product specific, but machine specific. So if I see something happening in a servo and in a temperature controller and they should not be happening at the same time, I can actually have it start to warn maintenance crews and operators before the machine would ever actually have problems. You also have one vendor support. So now if you bring in an engineer from the vendor, he is familiar with the drive, the motor, the controller, everything, the networking. So now you have one overall person for the support. We've seen this help us a lot with doing some of the advanced tracing and data logging that we're trying to do to raise what we refer to as OEE, or overall equipment effectiveness, at customers, to make sure that they're getting not only the highest throughput and the lowest amount of scrap, but make sure that that machine is running as many hours a day as it possibly can.
Well, thank you for joining me for this podcast, Greg and Eric. And of course, thanks to all of our listeners. And please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.